All right, guys, this will be just a quick and small extension on solving quadratics. Basically, what we're going to do is extend our ability to factor quadratics into factoring polynomials that are maybe cubic or quartic or have more than just two roots. But today we're going to really only focus on when one of those roots or all but two of those roots equals 0. So this is a polynomial here that is a cubic, and I've asked you to find the following function using mathematical vocabulary. I'll just write down a couple things here that I notice. It is going to have three roots. The y-intercept is 0. If we were to describe the end behavior of this function, I would say that as x approaches infinity, f of x would also approach infinity. And in the other direction, as x approaches negative infinity, this function would be approaching negative infinity as well. So those are some things that I'm able to gather just by looking at that equation there. And what we're going to do is we are going to actually find the roots of this polynomial. But the grouping method is not going to work because it's not a quadratic. This is a cubic. So we can't just do like 0 times 1. There's no method like that we could use here. So what we're going to do is we're going to use the Gcf method to break this down right now. So if I had x cubed minus x squared minus 2x, you'll notice that there is a greatest common factor of this entire expression, and that would be x. So I could bring an x out from each of these terms, and that will leave me with x times x squared minus x minus 2, right? And from that point, I could then just look at this piece as a quadratic, right? And that's just a quadratic with an a value of 1. So what I'm going to do is look at factors of negative 2 and 1, or 2 and negative 1, that also add to negative 1. So I want these two. So then I'm going to replace that with x minus 2 and x plus 1. All right, so we've factored that whole polynomial. Now, if I'm going to solve, then I'm going to have to take this thing and set it equal to 0. So x times x minus 2 times x plus 1 equals 0. Since I'm solving, I now have to set each of these factors equal to 0. So then we have three roots. X is equal to negative 1, x is equal to 2, and x is equal to 0. No solving there at all. So our final solution would just be negative 1, 0, and 2. And that should not come as a surprise to us because this is a cubic polynomial, right? The exponent is 3, so we know that there are three roots. The lucky thing is that we were able to factor out an x, which basically told us that 0 is going to be one of those roots. All right, let's do the same thing with g of x down here. It says to determine all the solutions of g of x. So what I'll do is I'll take my 3x cubed minus 7 x squared plus 2x. I'll set that equal to 0. All right, let me zoom in here. And now I can't use any of my my double bubble or factoring by grouping methods to solve this. So what I'm going to do is I'm just going to factor out an x. So now I have x times 3x squared minus 7x plus 2 equals 0. And that just resulted from grouping this and taking that x out of there. All right, we divided every term by x. And now what I'm going to need to do is I've got one x out of here, so I've already got one of my factors, but I need to find the other two. And now I'm just going to pretend like that doesn't exist for a little while and treat this like a quadratic, because that's all that is. So I'm looking for factors of 6 that add to negative 7. I've got 6 and 1. I've got 2 and 3. I've got negative 6 and negative 1, and negative 2 and negative 3. I want these two. So that's going to leave me with x times 3x squared minus 6x minus 1x plus 2 equals 0. Okay? And remember what I'm going to do here now. And it's okay if you want to separate this x and just leave it way out here for now and deal with all this other stuff. right? That's okay, as long as you know that x is being multiplied by everything that comes out of this piece. You could just look at it as big old brackets, and we're working within those brackets right now, but there is an x being multiplied by everything when we're done, okay? So now I'm going to take that quadratic I have here and group it. I'm going to find my greatest common factor and pull it out. So I'll have x times 3x times x minus 2 minus 1 times x minus 2. Remember, my GCF here is negative 1 because I want this to say x minus 2, not negative x plus 2. And this should be something that we're pretty fluent with at this point. Inside the parentheses, now I'm going to group this whole thing, and I'm going to factor out my x minus 2's. So that's going to leave me with x times x minus 2 times 3x minus 1. And now that I've done all that work, I don't really need those brackets to be there anymore. So that's not an absolutely necessary thing to have. Just helps us organize everything and see what we're working with. So now we have our three factors. It's kind of like above when we ended up with these three factors, right? We now have our three factors of this polynomial. And so to find the roots, because it's saying to determine all the solutions, we're going to set each of them equal to 0. So our roots are 0, 1/3, and 2. Right? This one's done. This would end up being x equals 2, and this would end up being 3x equals 1, or 1/3. All right? So you're going to find that we can do this with any degree polynomial as long as all our factors are zeros, or all our roots are zeros, except for 2 of them, right? Because we do know how to factor a quadratic, but we really don't know how to factor a cubic at this point, or anything that is a polynomial of a degree higher than 2 when our roots aren't 0. All right, so we'll get some more practice with this, but I'll see you guys tomorrow.